Howdy, AP PreCal, it's Ms. Kosh. This is the second part to my notes on 315, and I'm hoping my Apple Pencil has battery. Okay, I think it might. So we're going to jump into the average rate of change when it comes to the polar world. So hopefully this makes sense and we can jump right in. So if you remember, in a rectangular function, if I'm finding the average rate of change between 2 points that have input values x1 and x2, then the average rate of change is the change in y over the change in x. So what would the y values be? Well, it would be f of one of them minus f of the other one divided by that minus the input values subtracted from each other. So that's the average rate of change. So now what happens when we're talking polar? Well, now we have input values of theta 1 and theta 2. You could think of this as, you could say that the theta 1 would have a coordinate of r1 comma theta 1, and then r2 comma theta 2. And so you could use the R1s and that sort of thing, or you can use f of theta 1. I'm sorry, but hopefully my brain will wake up. I had a great trip to London, and now I am officially tired. So here we go. Looking at this one, we're talking about the function as f of, nope, I want to use 2, minus f of theta 1 divided by theta 2 minus theta 1. Or you could say that that would be the same thing as f of theta 2 would be the same thing as r2 minus r1 over theta 2 minus theta 1. I think this is more likely to be what you see in the AP world, but I really and truly haven't thought about this since a wonderful trip to the UK. So anyway, here we go. So find the exact and approximate value of the average rate of change between the 2 points on the polar curve below. Okay, so notice this is r is equal to 4 plus 4 sine theta. You could think of this as r is equal to f of theta, which is equal to 4 plus 4 sine theta. Or you can switch these two in whatever order. But sometimes that's helpful to see. So then what is this coordinate over here? This appears to be the theta value of pi over 6. It looks like to me it's got a radius of 6. Let's come over here and see if that makes sense. Pi over 6 does have a radius of 6. And then this is at pi over 3. Pi over 3. Its radius is a little harder to tell. We can come over here, pi over 3. That is not an exact value. Do you see how they rounded right here for us? What we'll do is instead we'll plug it back into the equation. So 4 plus 4 sine of pi over 3. Sine of pi over 3 is root 3 over 2. So this is 4 plus 4 times root 3 over 2 gives me 2 root 3. So the exact value, I need more space. Let's try that again. The exact value was, what did I just say? 4 plus 2 root 3 is the radius. Keep in mind, this is a little weird. We're used to having the input value first and the output value second, but now the input value is second and the output value is first. So just pay attention, be careful with that. Why did they do r theta? I don't have a good answer for you. If anyone comes up with a good answer as to why they write this output comma input, when our whole lives we're always doing, when we have x and then y, or x and then f of x, it's input and then output, which obviously is natural to us. If anyone knows why we do output comma input, let me know. Comment below. Let me know. Okay, so where were we? Here are our coordinates. So we need to do our r value. Don't forget parentheses. I was about to be wrong. Do you see how I was about to be wrong? Over, we can say, or actually, let's do it the other way. Watch this. Here we go. We're going to do you know why I decided to do it the other way? Because I didn't want to deal with negative angles. So this gives me 4 minus 6 is going to be negative 2. So this is negative 2 plus 2 root 3 is being divided by pi over 6. Okay, I don't know exactly where they're going to have us stop. So we could say this is negative 2 plus 2 root 3 is being multiplied by the reciprocal, so times 6 over pi. I tend to not like fractions in a fraction, like we're leaving it right here. But I need to go look and see what exactly they want us to do, what I see on AP Classroom. I don't remember off the top of my head. Like I said, I just came back from the UK. But this becomes, that is an average rate of change for this. So to find the approximate value, we would need to come to Desmos. I'm not sure if I have Desmos open. I didn't. So how you doing? We're doing well? Okay, glad to hear it. What did I just have? I had, my numerator was, oh dear, I forgot. -2 plus 2 root 3. Okay, so -2 plus 2 root 3 is my numerator, and it was being divided by, my denominator was, I don't know if I need that parentheses, let's see if I do, pi over 6. Okay, and so there's an approximate value for you. Maybe I'll remember to take a screenshot and add it to my notes, or my answer key. Okay, there's that one. I think we've answered the question. And then it says the actual values from the polar. So then I wrote this next part because I saw something on AP Classroom. The actual values of a polar function are given in the table below. Use the average rate of change from theta equals 0 to theta equals pi over 4 to estimate theta equals pi over 8. Was the estimate too high or too low? So, all right, here we go. Let's see. I've never taught this in my life, and I am jet lagged, so fingers crossed. If I have to make another video, so be it. Okay, so let's think about this for a second. Our average rate of change, yep, I think my pencil's dying. Well, I think I have a second pencil. So we'll see if it works. Okay, average rate of change was equal to what? It was equal to f of theta 2 minus f of theta 1 over theta 2 minus theta 1. Okay, let's hang on to that piece of information for a minute. And we can use the fact we're trying to find the average rate of change between these two. So we have 7, that's not a 7. We have 7 root 2 minus the minus 7 halves is being divided by pi over 4 minus 0. Okay, ugh, that wasn't very nice of me. So we have 7 root 2 minus 7 over 2 is all getting multiplied by 4 over pi. 28 root 2 minus 14, each of them is over pi. Or we could put them both over the same pi. Maybe we'll do that. There we go. Okay. So that right here is the average rate of change. Okay, so then we want to say, well, let's use this equation and plug in. We're going to now use, I'm going to change colors. We're going to now use these first two, partly because the 0 is nice to work with. Did I do this correctly? No! Okay, you guys, who caught my mistake? Haha, this makes this so much easier. Okay, woo! All right, what did I do wrong? Well, I used not the correct output value. Okay, oh, good. Jet lag. Can I blame jet lag? Here we go. So I'm using the one I did in blue, so it's 7 pi over 2, or no, I lied, 7 root 2 minus 0 is equal to pi over 4 minus 0. So now we've got, let's get rid of this equal sign, I don't know what I'm doing. This is 7 root 2 times the reciprocal, so times 4 over pi, which is going to be equal to 28 root 2 over pi. Okay, so did y'all catch my mistake before I did? Good job if you did. Bonus points for you, especially if you're not one of my students. Okay, so now what we want to do is we want to use the, and that's why this was, did you notice how I caught my mistake? I recognized here that I wanted 0 and 0. That's why I picked those two to work with, but then I hadn't done that, so that makes a difference. Okay, so now we can say that the average rate of change, which was 28 root 2 over pi, is equal to f of, I'm going to write it this way, f of pi over 8 minus f of 0 over pi over 8 minus 0. Okay, well, so what were those values? We have 28 root 2 over pi is equal to f of pi pi over 8 was 7/2 minus 0 over pi over 8. No, what am I doing wrong? Oh, okay. I'm trying to find what that approximately is using the, can you tell? I've never taught this before. This is what I'm looking for. So this is f of pi over 8. I'm trying to figure out what that approximately equals. So minus 0. So my ultimate goal is to solve for that variable right there. So what do I have? Well, I have 28 root 2 over pi is equal to f of pi over 8 times the reciprocal of that, so 8 over pi. So if I divide both sides by pi over 8, or if I multiply both sides, no, if I multiply this by pi over 8, I can multiply this by pi over 8. Yeah, because I was dividing by the reciprocal. Dividing by pi over 8 means multiplying by the reciprocal. So I multiply by the reciprocal of the reciprocal. Oh, my goodness. Okay, that was hard. That was too hard. Let me get some sleep tonight is really what needs to happen. So here's what we were looking at. Let me say it a little bit better. I'm dividing by pi over 8, so if I multiply both sides by pi over 8, then I just have f of pi over 8 on that side. Okay, so then what happens? The pi's cancel. Here, let's use another color. Pi's cancel here and here. 28 over 8 is 7. Am I right? No, what is wrong with me? 28 divided by, that's 7/2. So 7/2 root 2 is equal to f of pi over 8. Yes, okay, 2 goes in here 4, 2 goes in there 14. 2 goes in there 2, 2 goes in there 7. Oh my goodness, you guys. Okay, so we just found that the approximate value would be, 7 root 2 over 2 is equal to this f of pi over 8. But from the table, we had that pi over 8 was equal to 7/2. So now what we want to do is we want to figure out how far off were we. Okay, so let's come back to Desmos. What did we have? 7 root 2 over 2. Okay. 7 root 2 over 2 is approximately that big, whereas 7/2 is 3.5. So we are over, so take that number and then subtract away 3.5. And we were too big by 1.5-ish. Not quite, but that sort of thing. I forgot to do a screen capture for the other part. Oh, well, that's too bad. Okay, so was the estimate too high or too low? The estimate was too high. How far off was it? About 1.5, 1.44 or something like that. Hopefully that made sense. I'm sorry for my jet lag, but I had a great trip, and I hope that was helpful. Comment below, subscribe, come back, let me know how I can help you. Good luck. Go steady.